So in this video, we're going to see a demonstration of a jump instruction using a CPU that I've built in Minecraft. So a few notes before we get into this. This was built a long time ago, and when I built it, I didn't quite understand all that I was doing. So there's a lot of funky wiring things going on. Like you can see here, this is just a mess. All the red is the control circuitry, and it's just so wrong. There's this massive decoder here that does not need to be this big. And that does affect how the jump instruction is implemented. So in this computer, you see this program counter here. It increments when it jumps. It doesn't completely rewrite it with a new bit of data, it just increments, which is not how it's supposed to be implemented, as we covered, but it is what it is. And in case you're wondering why it's not supposed to increment, because you only end up with a single byte or single piece of data or instruction to work with, and the only thing that you can really do with that is stop the computer. So it's really not that useful. And the other point I wanted to mention is that we can, if you look at all the different pretty colorful circuits, we can see different parts of the computer that we have covered throughout this module. So we can see all of this blue circuit is memory. The red, once again, is control logic. So this guy down here is all decoder. Orange is the ALU. Cyan circuits are registers. And we can see over here, brown and yellow, these are also decoders, but these just decode the memory address, and then they can read and write to memory through there. So let's get into this program. So we can start the clock on the computer, and you can see it starts incrementing like this. So you can see it's 3, now it's 4, 5. The jump instruction is held at jump location 7, or memory address 7. So we can go there, and you can see it goes to 8 and then immediately jumps to 9. So 8 is a halt instruction, and it passes right past it, so the computer does not halt. And so it can go for a couple more instructions just to clear and reset the computer, and then it halts immediately after. This is done because I've ran into a number of bugs trying to make any longer programs with it, and even then, the program length is a maximum of 15 lines of code. So that's not really a lot. 15 instructions and data combined is not enough to make a complicated program, but it doesn't matter because it's buggy anyways. We can run this one more time so you can see all that the computer's doing. So first and foremost, it's going to write to one of the registers like that, 15, and it's going to write 1 to the other one, and it's going to write that to the ALU, which is going 15 plus 1 is 16, which is going to cause an overflow, just like that, which is going to go into the program counter and incremented by 1. So that's the hurried, rushed version of it. But just to show you what happens when it doesn't jump, I can wait for this to halt and then go over here to this instruction. Well, this is data actually. This memory cell holds the data for the second register. So now it should write a 0 to the second register. And when it writes the 0 and sends it to the ALU, it should do 15 plus 0, which is 15, which should not overflow. So you can see 15, other register doesn't have any data sent to it, so it doesn't overflow. We can see it goes to 7, goes to 8, and does not skip to 9, and just halts right there. Whole machine stops. So that is it for this video, and this is also the last video in the series and for this module. So thank you for watching, and I hope you enjoyed.